You're watching Sitka Community TV. Be sure to like and subscribe if you like what you see.
Hello, everybody. Welcome to today's meeting. If everyone could please stand and join in the pledge. I pledge allegiance
To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you. Sit down. Welcome to today's meeting. Happy to see you guys all here. I would like to just mention our land acknowledgement. The Tlingit people have been indigenous to this land for over 10,000 years. I can't say the word, please. To the Tlingit people for their stewardship of Tlingit Ani since the time immemorial and today. Do we have any visiting Rotarians?
No, I'm not a Rotarian.
You're close. Rotarian adjacent. Ed.
We have a guest, Mario Hackett. He's been here before. I think everybody knows him.
Okay, Norm.
Once again, I brought my favorite wine.
Introduce my wife, Susan Clear.
Okay, and then in the middle here we have,
So I'm Melissa Henshaw, you guys know me, City Public and Government Relations Director, and I also brought
Yay.
David Johnson to talk about volcanoes and what may happen with them.
A future Rotarian.
great, thank you so much.
Which one?
Okay, do we have any announcements, any Rotary announcements? Okay, non-Rotary announcements?
Hi everybody, good morning, good afternoon. Just to let you know that this weekend, Sitka Homeless Coalition will be receiving a barbecue fundraiser at the lakeside. I know you all like coming down to eat. We keep doing these for all these nonprofits here in Sitka. Our feature this week is a smashed beef gyro with tzatziki sauce. 100% of the proceeds will go directly to the Homeless Coalition. Food's donated, time's donated. Sitka Bottling and Northern Sales Sitka are big donors as well. Come down and support.
Okay, so we started a little early. We're going to get started quickly with our program because there's probably going to be questions at the end, so I want to give time for that. I just want to say one announcement for next week. Normally, I know in Rotary, we don't like the business meetings. We like to hear speakers, but we're going to have a business meeting next week. And it's kind of going to be what I would like to accomplish this year, so I'd really appreciate if anyone who's in town can be here. If not, please be on Zoom if at all possible. And I am going to arrange so there will be food. So we'll have lunch provided of some sort as hopefully a hook to get you here. And if you guys have, we're going to talk about committees, we're going to talk about projects, and it's going to be back and forth. It's not going to be me just talking. We're all going to work together and figure out where we want to go this year. And if it doesn't align with where I want to go, then we'll figure it out. And we'll go where most of the people want to go here for the year.
Follow you.
So, well, hopefully you follow me, but all my ideas might not be great ideas. And if you guys have different ones, then I want you guys all involved so that we move the club where we all want it to go. Anyway, okay, so with that, I'm going to have Ed come up and introduce our speaker.
We'll see if we can make this all work. Our speaker today is going to be with us by Zoom. She is Cheryl Cameron. I'm going to give you her title, Chief Volcanology Section, Alaska Division of Geological and Geophysical Surveys, Alaska Volcano Observatory. Some of us were here, it's been a month or two, when she made a presentation to the city of Sitka. And I look out at Mount Edgecumbe every day when I get up and when I go to sleep. And it's really important to me to know what's going on, and I'm sure it's the same for the rest of the city of Sitka. Cheryl's going to give us an update on the volcano, assuming we can share, and look at that. somebody knows what they're doing. But,
Can you move your head, please?
me?
No, him.
Or you can move a little over to the side, yeah?
Jeff can just go to.
Sorry, Cheryl, this is the way the club works here. And with that, I'll turn it over to Cheryl Cameron. Let's see if we can hear, and can you hear us, Cheryl?
Great, too. It's great. I can hear you and I can see people in the room, although you're all really tiny now because I showed my screen.
Okay, great.
Can you hear me?
Yes.
Loud and clear.
All right. Yeah, so Ed approached me about giving this talk, which is essentially the same one that Christy and I gave to a number of places in Sitka when we were there in early May. And of course, I planned to be there in person at this time, but our plans had to change a little, and so I'm here by Zoom, and we will be back in August. And so this is a short little presentation about Alaska Volcano Observatory and the work we are doing to monitor and study Shaw or Mount Edgecumbe. And I'm trying to figure out how to make my slides go forward. There we go. So a quick little orientation to the Mount Edgecumbe volcanic field from kind of a geology perspective. I think a lot of Sitkans are really familiar with exactly where Mount Edgecumbe is. This is a picture taken from the C-Mart parking lot on Christy Wallace's first ever day in Sitka. It was beautiful. So that's Mount Edgecumbe, but really geologists, we think of the Mount Edgecumbe volcanic field because it's a much bigger region. And so over on the right side of the screen, you see this
recording in progress.
This lovely little LiDAR topography map, and you can see all of those little perfect volcanic vents and cones. Those are all part of the Mount Edgecumbe volcanic field, which doesn't reach the northern part of Kruzof Island, although the field does extend in the submarine towards the southwest. And so, particularly people fishing, using fish finders, can see those underwater vents. Crater Ridge, which is a prominent feature just to the northeast of Mount Edgecumbe, is of course a part of the field. And so that's just a quick little thing about what we're talking about. So I work for the Alaska Volcano Observatory, and AVO has 3 main objectives. We monitor and conduct scientific investigations in order to assess nature, timing, and likelihood of volcanic eruptions. We assess volcanic hazards associated with those anticipated eruptions, and we provide timely and accurate information on volcanic hazards and warnings of dangerous activity to local, state, federal officials and the public. And so this slide also has a number of pictures. It has some of our monitoring stations, instrumentation. You can see basically the solar panels are sticking out of the snow, a little tiny thumbnail of a geologic hazard assessment for Great Sitkan volcano, and our ground-based volcano alert levels and aviation color codes with, the colors are for hazard to aviation and ground-based levels are hazards on the ground. And generally in Alaska, those two things are always paired. So I think this is the part most people are interested in, low-level volcanic unrest at our very own Mount Edgecumbe. So this first came to our attention April 2022. Mount Edgecumbe was classed as a moderate threat level by the National Volcano Early Warning System program. A number of years ago, that was most recently updated in 2018. At that time, we had no indications of any unrest happening at Mount Edgecumbe. Hadn't had an eruption in hundreds of years, perhaps thousands. But my brother, who now lives in Anchorage, he pays attention to a lot of things, and he sent me this little picture here of an earthquake that was auto-located on the Alaska Earthquake Center Regional Seismic Network. And it's a fairly small quake, it's 2.1, but it's directly underneath Mount Edgecumbe, and it's very shallow. And he said, "Hey sis, what's up with this?" And I'm like, "I don't know, Sitka's right on the Queen Charlotte Fault, tectonic earthquakes are normal." I said, "I'll ask a seismologist anyway." And so I posted it to our internal chat channels, and a seismologist got right back to me, and he was like, "Not to alarm anyone, but it looks like a swarm." And this was the picture of what that nearest seismic station in Sitka looked like in April of 2022. And what you can see is that these are many, many, many small earthquakes, much too small to be located, and they are just chucking along, going tick, 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 tick. It's a pretty classically volcanic picture, but at that time, we still didn't know. We couldn't say for certain whether or not the earthquake activity was related to anything volcanic. And so, oh, I'm missing a slide. That's okay. Seismologists and geodesists at the Alaska Volcano Observatory did some retrospective studies using existing data to try to determine what was going on and if there was a linkage. And to make a long story short, they found out, yes, that earthquakes are linked to volcanic activity. So up here in the upper right, you can see this is a little plot of located earthquakes at Mount Edgecumbe. The blue ones are just older than the red ones. And so you can see the seismicity, and it's really concentrated right under the volcanic field. But the icing on the cake was doing retrospective analysis using satellite data. INSAR satellites, they take a pass over an area and they send a radar beam down that makes a very accurate map of the Earth's surface, and so you can compare successive passes to see changes in elevation. And so when they did that, they found that the area right around Mount Edgecumbe proper has been experiencing ground surface uplift. It's been fairly constant since about mid-2018 at a rate just under 4 inches per year. So if you were standing at this rate where the highest uplift has been occurring, which is kind of just a little bit to the northeast of the summit of Mount Edgecumbe proper, it's about 20 inches higher than it was several years ago. This graph was made in April, but the deformation picture hasn't changed. It continues to just chug along at that kind of steady rate. And so Ronnie Grappentine and his colleagues have done some sophisticated modeling of looking at the deformation changes that have happened at Mount Edgecumbe to try to figure out what's going on underneath the surface that best fits with the changes we see at the surface. And so what fits best is that there's magma intruding underneath Mount Edgecumbe at about 6 miles deep, that's 10 kilometers, and it's intruding into an area that is kind of, thin and pancake shaped. And we don't see any signs right now that that magma is progressing any closer to the surface than about that 6 mile depth. So here's some recent located earthquakes. You can see that April 2022 seismic swarm shows up really well. And since then, we haven't had a whole lot of earthquakes. This is the one slide I did update a tiny bit since May for this talk, because on May 30th, there was a little tiny seismic swarm, not as big as the one in April 2022. The events were too small to be located because the regional network in Southeast Alaska is fairly sparse. And right now, AVO has just one seismometer on the edifice, which is not enough to locate earthquakes UV4. The dots are sized by magnitude of the earthquake, and this largest one that's down here in the lower right, it's just about a month old, and it's a 2.3. So, when we're talking about earthquakes related to volcanoes, we're talking very, very small earthquakes that are produced by magma or fluid movement. So the short story, a magmatic intrusion. What does that mean? It's only within the last couple of decades that we are able to detect magmatic intrusions below the surface of the Earth before they make it to the surface. And so what we know from this limited data set is that some magmatic intrusions erupt and many do not. So Semi-Sapochnoi, way out in the Western Aleutians, had a similar sort of uplift in magma intrusion rates for 2 years in 2014 and 2015, and then it did nothing for 3 years, and then it started erupting in about 2018 and has been kind of having a low-level eruption ever since. Akitan had some really striking magmatic intrusions, especially in 1996. There was a much greater seismicity than what we see now at Edgecumbe. There was more inflation. The magma made it close enough to the ground surface that these cracks opened up, and yet still there was no eruption. It did not make it to the surface. Pulik and Iliamna and Dutton have all had magmatic intrusions without eruption. Aniakchak has been experiencing some striking rates of inflation, and we're watching it really closely. And so the three things that could happen from where we are now with Mount Edgecumbe is that unrest could end, it could continue, or it could escalate. And if it did escalate, we would issue warnings. And when we think about what might happen, it's also good to keep in mind that what we think happened, the most recent eruptions, both from geologic history and from Tlingit oral history, the recent eruptions were smaller than some of the bigger ones in the late Pleistocene past of Mount Edgecumbe. So I mentioned Tlingit oral history, and I want to take a minute to express our gratitude for Tlingit people sharing their stories with us of volcanic activity at Mount Edgecumbe. It's helped improve our understanding of timing of events, that there were these very possibly quite recent eruptions that may or may not be preserved in the geologic record. It helps improve our understanding of the most recent eruptive style, a rather low-level intermittent process that went on. And these things feed into a more informed understanding of possible hazards, especially as we start to look towards, what the most likely possibilities are from where we are now. So what we would expect to see if the unrest is leading towards an eruption, we're really confident that we would see more earthquakes, and we would see heat, and we would see gas, and we would see a change in that deformation rate. We strongly believe that we would have weeks to months of this heightened activity prior to any eruption at Mount Edgecumbe. So I thought I'd take a few minutes to talk about just how AVO monitors volcanic activity throughout Alaska. The workhorse of our volcano monitoring is seismic instruments. Seismicity measures ground shaking. We also increasingly use infrasound to detect eruptions that have happened. Those are useful for explosion airwaves. We use lightning to detect eruptions that have happened in ash and ice clouds. We monitor with gas emissions, both ground-based, plane-based, and from space. We use GPS for ground deformation. We use our geology and geochemical studies because what's happened, our knowledge of the past eruptions are our best guide to what could happen in the future. We use a lot of satellite remote sensing, and we love and very deeply appreciate eyewitness report from, citizens, pilot reports, webcams, because our offices in Fairbanks and Anchorage are not actually close to volcanoes in Alaska. And so we are grateful for observer reports and photos and videos that we receive from people who do live much closer to the volcanoes. And so this is a little map of some of our ground-based monitoring. So you can see this is largely centered on Cook Inlet, the Alaska Peninsula, and out to the Aleutian Islands. Each one of those dots represents what we call a station. We maintain more than 200 seismic stations throughout Alaska, centered on Alaska's volcanoes. We've been doing this since 1988, and so we have experience in keeping our stations hardened for remote weather conditions. We try to make them as bear resistant as possible, but bears are intensely curious and very destructive, so nothing is perfect. And you can see on this gray map here, I don't know if the audience can tell, there's a little tiny red dot in the Gulf of Alaska with an arrow pointing eastward, and it says Edgecumbe. All of our aspect ratios for all of our maps need to be changed. They were already too long and skinny with the Aleutians, and now we need to figure out a way to get over to Southeast Alaska. It's very important to me. But see, I have a little inset map here down in the lower right, and you can see there's one black triangle on Edgecumbe, so that is our one station that currently exists on Crusoe Island. So our current monitoring status, Mount Edgecumbe, one broadband seismometer on Crater Ridge installed in May of 2022, and paired with that is one GPS sensor for ground deformation. We also are now heavily using the regional seismic network. The nearest station is in Sitka, just 15 miles east, and that's maintained by the National Tsunami Warning Center folk. We're also using the FAA webcam in Sitka, our regional infrasound network, satellite lightning detection, and of course, eyewitness accounts. Here are some pictures of what the station currently looks like or used to look like. So in May, we put in a temporary station. So you can see it's kind of just that aluminum box. It's our station in a box. And then it came back in August to make it more long-term, to make it able to get through some winters. And so we have a fiberglass hut, and the fiberglass hut provides shelter for The digitizers, the telemetry, and the batteries. The seismometer itself is buried a short distance away from the station, and the seismometers are fairly small. They're about the size of like an oversized Coke can. We have a GPS monument installed also off to the side of the hut. Right now, it's a kind of temporary situation with cables, but when we come back later this summer, our GPS monuments, we're going to make them much more sturdy and robust with metal poles instead of cables, and that'll improve our data and it'll improve the longevity of the station. And so what we want to do next is we want to install additional instrumentation near the volcano. People probably heard about NASA early career funded research project at Mount Edgecumbe earlier summer to do gas work. So a bunch of that team is people who are also AVO personnel, and they plan to also come back later this summer to continue their gas work. Measuring water temperatures on the eastern shore of Crusoe Island. They did some of that in June, and I think they'll probably do more of it. We want to work on our geologic studies and of course continue community engagement and collaboration. So our new instruments. We want to install 3 more stations on Mount Edgecumbe, and you can see that they are the pink stars. The yellow star is our existing station. If we can, we want to put in a webcam over on the west side of Crusoe, because web cameras are extremely helpful to us, not just in looking at the volcano to see what might be happening visually, but also for looking at weather conditions. And we often try to put our stations in view because sometimes we can visually tell what's going wrong if there's a webcam that gives us a picture. All of our data from these stations will be online and accessible to the public. This is a slide about the gas work. Much of this work did get to happen in June when Claire and other people were there. They did collect a few CO2, but the levels they found were extremely low, and so they've got to do a bunch of more work to analyze them. Thanks to Sitka's reporting bubbling on the eastern shore of Crusoe Island, they were able to go there. They did observe the bubbling. They did collect samples. Right now, they still don't know if the bubbles are related to something volcanic or to something more biogenic, not related to the volcano, but they want to come back in August. They're going to collect more samples, and hopefully we'll be able to complete their assessment later this summer. We want to do some work on further geologic study. There's a pretty good map of the Mount Edgecumbe volcanic field from the late 80s done by Jim Riley and others. We would like to do some petrologic and geochemical analyses that can help us learn more about magma storage and conditions of past magmas that erupted at Mount Edgecumbe, because that might give us some insight into what the current magma that's intruding underneath the volcano looks like, since we think we know its pressure and temperature conditions, but we don't know its chemical composition. We could work backwards from known compositions to get to where they were stored to see if it's in a similar place or not. We're coordinating efforts with Britta Jensen's group out of Alberta, Canada, as well as other researchers. So you may hear, different people coming from different organizations to do work. And we would like to do more detailed mapping and hazard assessment after LIDAR data is collected over Mount Edgecumbe later this summer. And so if you're wondering how you could follow Alaska Volcano Observatory updates on Mount Edgecumbe, you could come to our website. This is our Mount Edgecumbe page, and you notice that it says it's color code unassigned and alert level unassigned, and that's because we don't have enough instrumentation installed at Mount Edgecumbe in order to assign an alert level. If we thought that there was serious unrest happening at Mount Edgecumbe that warranted an elevated alert level, we would do that. We would move it to yellow or orange or red, but we can't call it green until we have all of our instrumentation in and background levels assessed. So that's just an operational note there if you're curious. And lastly, we really appreciate anybody who sends us observations, especially if you have felt earthquakes or you smell sulfur, see steaming or bubbling water. If you reach out and let us know, either by the contact us link on our website or Facebook or Twitter, that's wonderful. And if you want to receive volcano notification products in your inbox, then you can sign up for what we call the Volcano Notification Service, and that is that volcanoes.usgs.gov link there. You can go there and tell that service what volcanoes you're interested in and what type of products, and you can make it completely custom. And every single one of those emails also comes with an unsubscribe button at the bottom. And so that is all I have prepared, but I'm really happy to take questions.
Okay, if you have questions, raise your hand. I'll just kind of point and you can blurt it out.
So did I hear correctly that the level of Mount Edgecumbe has gone up 20 feet? Is that correct?
20 inches.
Oh, 20 inches. That's a big difference.
Yes.
I was wondering whether it was much more strenuous to climb than it was earlier, but not 20 inches.
Yes.
And I have a question with Crater Ridge and Mount Edgecumbe. Were they at one time one big volcano, or is that two separate volcanoes?
It depends on, what definition you use of volcano. Like, people can go down in the weeds here quite a bit. We consider them, they are separate volcanoes within the same volcanic field. And so, they're closely related to each other. They have had their own separate eruptions at different, but sometimes also the same points in time. Like, that is one of the complexities of the Mount Edgecumbe volcanic field, is that there was a time in the late Pleistocene when it looks like, from the geologic record, that Mount Edgecumbe and Crater Ridge were both erupting pretty much at the same time with each other. The products from those two volcanoes kind of interleave with each other in ways that suggest contemporaneous eruptions. But we think that that eruption series was triggered by ice unloading from the retreat of the glaciers in the end of the last ice age.
I have a question for you, Cheryl, if you can hear me. Based on the historical record and what we know of Alaska volcanoes, if the volcano erupted, what could we expect?
That's a great question. So the biggest hazard to Alaskans from volcanic eruptions is volcanic ash. And volcanic ash can be a problem for Alaskans in two ways. The first one is that ash and aviation don't mix, and so when there's ash in the atmosphere, planes can't fly. And so this is a problem for transporting people, but also goods and transportation, since we are such an aviation-reliant state. And the other problem is, of course, ash fall. And so that's ash falling onto communities and infrastructure. Ash is very abrasive. Ash can be heavy, especially if it gets wet. Most of the time, ashfall on Alaska communities is what we call a nuisance. It's a stay inside and be careful in cleaning it up later. And we have a lot of guidance on exactly how to clean up ashfall for a lot of different industries and applications. The USGS has a great website on this. If I scroll through my unused slides at the end of the presentation, I think I have one. So don't judge. Oh, no, I didn't put them in. I'm so sorry. I could navigate there and share the page. Or I could send it to Ed after the meeting and he could distribute it to the Rotary. This may be a better way to go.
Okay, I can make sure that gets distributed.
Thanks.
Another question I have is, how soon will the additional monitoring be in place and you'll be able to have a better idea of what's going on?
Yeah, so as folks know, we originally planned to do the monitoring in early May, but we had some delays, and we are now all scheduled and set, and I think everything is checked off for August 20th through 29th. We're still looking for affordable housing, so if anybody has a lead on a place where about 6 people could stay relatively cheaply in Sitka, definitely let me know.
Okay, if something comes up, we'll funnel that to you.
Wonderful.
Anybody? Okay, Melissa.
So, hi Cheryl, it's Melissa Henshaw.
Hi, Melissa.
So do you still consider this volcano dormant?
No, this volcano now meets our criteria for being active due to having an ongoing magma intrusion under its surface.
Okay, so if something were more to happen, how does AVO like issue warnings and how do they communicate that out?
Yeah, that's wonderful. So if, I mentioned earlier that we believe we would have months to weeks of heightened activity prior to any eruption. And so if we started detecting that elevated activity through our data streams, then we would issue notifications and products. We would elevate Mount Edgecumbe's volcano alert level and aviation color code. And so those products would be released via our volcano notification service. They would be on our website. We have call down procedures to local, state, and federal officials and agencies. And so we would keep everybody in the loop, and we would definitely come back and talk to Sitkans more. So yeah, we would work hard to distribute that information as broadly as possible.
Cool. Thank you.
Let's see, Jeff, well, Catherine first.
It's okay, Jeff.
Oh, she had her hand up. All right, so the worst case scenario, what could or should we be preparing for? By a vote, get the hell out of here.
So I have a lot of friends and family who live in Sitka, and if I had a nice place to live in Sitka and a job in Sitka, I would definitely be happy to live there. I'm definitely not encouraging my friends and family to move or to leave. I think, we prepare for what we think is the most likely scenario and not the worst case scenario. So right now there's a magmatic intrusion happening under Edgecumbe. It may or may not make it to the surface. If it does start making its way to the surface, it's not like there's a empty space that magma can just go into. Edgecumbe has not erupted in hundreds, perhaps thousands of years. The geologic record, the youngest eruption from Edgecumbe is about 4,000 years old. And so there's no open pathway for magma to go to the surface. Magma is going to have to break rock on its way up, and those are going to make earthquakes that we can detect. So there's going to be advanced warning ahead of any eruption of Edgecumbe. And people who have experienced volcanic eruptions, maybe you've lived in Anchorage for one of the spur or radite eruptions. Volcanic ash is a problem, but it's a temporary problem. You generally want to keep it out of your lungs when it's falling, and then to clean it up in safe manners, rather than a sky is falling, world is ending sort of frame of things, if that makes sense. And there's going to be time.
Okay.
Thanks. I had two questions. The first was, how long do your people need housing for?
I'm sorry, I couldn't hear the end of it.
I was curious how long your people need housing for to do that.
Oh, about the 19th through the 29th.
Okay, so just like 10 days.
Yep.
Okay. And then my second question, I was curious if you could go back to that, one of your earliest slides where it had I think it was a white chart with a -3 at the top, a 0, and then it went.
Earthquakes.
Yeah, could you go back to that? Because I didn't quite understand it, and I wanted to ask.
Sure. Let me get there.
Well, essentially, that numbering on the side, what does that pertain to when you get there?
This is depth in kilometers
So is it,
below sea level.
so that's from how deep the earthquake was from sea level?
Yes.
So it was, could you make it bigger for me? I'm sorry.
I don't know if I can do this.
Oh, sorry. Yeah, thanks.
Okay.
So that slide is saying that in April, it was 3 feet below sea level?
So depth in kilometers.
Sorry, but is that what it's saying? And then it was
So-
up to almost like 8 feet above sea level?
So these are the earthquake locations plotted by depth below sea level on the y-axis and time on the x-axis. And so each one of these little orange circles is a located earthquake. But keep in mind that these locations are poor because we don't have a robust seismic network on Edgecumbe. And so, and depth is really hard to constrain when your seismic network is poor and your stations aren't configured. Like all of our stations sit to the east of Mount Edgecumbe. And what we want ideally is to surround Mount Edgecumbe. And so it's depth below an arbitrary elevation set as sea level, and it's in kilometers.
Thank you so much.
So I think you really want to know is how do you get a negative depth?
No, that
on it?
makes sense to me because
Okay.
it's a mountain that goes higher than the sea level, and so it's below
Yeah, two
as
things,
well.
yeah.
That makes,
A mountain
It's not
that goes
3
higher than
kilometers
sea
high.
level, plus poor locations because the network is sparse and isn't configured in a great way to locate anything on Crusoe Island.
thank you.
Before I jump in, any other questions?
We
Yes.
talked about what your expectations are, but we also know that volcanoes have a mind of their own, as history has shown. We talked about volcanic dust and ash, which I've dealt with in the past, but I am curious, what is the catastrophic side of it? Because you say prepare for maybe, well, what is the worst case scenario? What could possibly happen? Because volcanoes don't always do what we say they're going to do.
Well, so if you look around town and you see that there's what looks like about 3 feet of ash, underneath everything, it's important to keep in mind that that 3 feet of ash is not in fact one ginormous eruption. What we know from Marine Corps studies around Sitka is that ash represents more than 20 separate eruptions. But once you dig into that stratigraphic package of those many ash layers, it is true that some of those eruptions are quite large, several inches thick, which would be fairly catastrophic for Sitka. Those would be a very bad day, to put it mildly. I would not suggest anybody to be in the vicinity of Sitka for an eruption of that size, but I think that is an extremely low probability.
I respect that. I was just curious because, we're always looking at the mile part, but you want to know what the spectrum is, not kind of sugarcoat it and all. What would be the expectation of the water levels and all if we do get an eruption? Because we are kind of shallow out there and we're kind of close to it.
Yeah, so in the late Pleistocene, which is when those big packages of volcanic ash were deposited that you do see around town, there were pyroclastic flows from Mount Edgecumbe Crater Ridge that did reach the ocean, although it's a little hard to extrapolate what would happen now because sea levels were lower back then than they are now, and so it's not certain what that ash and water interaction was then or what it would be now. I think that it's highly unlikely that anything like extremely, extremely, extremely unlikely that anything like a pyroclastic flow from Mount Edgecumbe would reach Sitka. We're just now starting to do work on any possible tsunami modeling, but I also think that is an extreme outside problem. The biggest problem is likely to be ash in the atmosphere and ashfall.
Okay, thank you.
Yeah, and I thought this slide might help, talking about warning times, especially in the context of other sort of natural disasters and phenomenon, you think about extreme weather events like hurricanes, and the forecasters might start talking about a possible hurricane, a week ahead of time, and then you get more solid information days to hours ahead of time, and that's not a lot of warning. You talk about earthquakes, which is not possible to predict. They don't give any warning. Floods, can provide weeks to months of warning, but volcanoes, sometimes provide decades of warning.
Jeff?
I was going to make the comment, when the fire chief was here, he said his biggest concern was the ash getting into the water system.
That would be one of my concerns too. So Sitka does have, a surface water reservoir system, which could be contaminated with ash, which could cause problems, and you might need to take care of the pumps, or there might need special flocculants or filters or things. And the USGS Asphalt Preparedness website has a lot of very specific guidance for all of these types of situations. So there's an international team of researchers that does contain people from AVO. Actually, Christy Wallace, who was in Sitka in May, is one of the major people who works on this sort of study and work, who have analyzed volcanic eruptions and ashfall events from all over the world to help develop this guidance. And we have an interagency ash plan that gets set in motion anytime that there is a volcanic eruption.
Okay, any other questions, comments, thoughts? Lauren?
So, don't quite know how to phrase this, but you kind of talked about earthquake swarms and elevation raising 20 inches. How do you compare or contrast that to maybe Mount St. Helens? I mean, for how many years was Mount St. Helens raising, and did it have a magma vent? I mean, do you compare similar situations, other volcanic data?
Sure. Yeah, no, that's a good question, because that is one of the first things that we do when we encounter unrest or possible volcanic unrest at a volcano that doesn't have a lot of study or monitoring on it, is we look for what we call analog volcanoes, something similar somewhere else that we do know more information about. The Mount St. Helens question is tricky because we have a lot of tools right now that were not available in 1980. In 1980, the idea of seeing deformation on the centimeter scale from space, for years and years ahead of the 1980 eruption, we didn't have that. We've come a long way in our understanding of volcanic eruptions and processes since 1980. Even said at 1980, there were a lot of really specific warnings given to people. People at Spirit Lake were told to evacuate. They had time to leave. They chose not to. So it's hard to say what was happening at Mount St. Helens prior to the 1980 eruption versus what's happening at Mount Edgecumbe now, just because the data we have now is so much better. The preliminary modeling of the amount of magma that's intruding under Edgecumbe right now is not Mount St. Helens sized, so that's nice. So when we look through, especially what we know from Alaska and our magmatic intrusion knowledge, that is some of the information that we collected to put on this page. The rates of intrusion that are happening at Mount Edgecumbe now are significant, and they are not what we call small, but they are also not the largest that we are looking at. In Aniakchak, which is a volcano on the Alaska Peninsula that most recently erupted in 1939. In February and April, all of us at AVO became very concerned because there were extreme uplift rates at Aniakchak that exceeded an inch per week. Keep in mind that Mount Edgecumbe has been trucking along at less than 4 inches per year. And so an inch per week is much larger. But following that uplift in April, the rate of uplift has slowed. It is still experiencing uplift, but it is not as intense as it was. And here we are in July, and it has not erupted yet. And maybe it will, maybe it doesn't. Aniakchak is currently sitting at yellow on our AVO color warning scale.
Okay, any last chance for questions, comments? Cheryl, we appreciate your time. We hope we get you back in person sometime with an update in the future. This is just critical to everything that happens here. I can tell you, as a person who lived my whole life in the threat of wildfires and earthquakes in Southern California, I'd rather be here than there. But it's forewarned is forearmed, so this information is super helpful to us. So thank you very much.
I will send you guys a little collection of how to sign up for the volcano notification service and the asphalt preparedness website information, and of course my email. If anybody has further questions or concerns or wants to send us a note, please do feel free to contact me. I'm grateful for the chance to say hello to you today, and we'll stay in touch.
Very good, thank you.
Thanks. Bye.
Bye. Thank you so much. Okay, do we have any other announcements from the club? Catherine?
No.
Questions? No? Okay, well then, I guess hopefully we'll see all or most of you next week.
Well, sir.
Mr. Fire Department.
Besides Mount Edgecumbe.
Yeah, I went to, oh, you did?
For the volcanic observatory, we need to go to the, maybe you have better stories about volcanoes.
My mind wanders. Talk about maybe they have one
My question is, how does this affect?
You're watching Sitka Community TV. Be sure to like and subscribe if you like what you see.